This is Lab 4, registers and ports. Up to this point we've added just a little bit more hardware so that the computer can actually do something. We've added a couple transistors, some passive components, and the two LED displays. This circuitry will be driven by output pins on the 8155 RAM I/O timer chip. Now we're going to pretend we're the CPU by manually providing input addresses and data to the 8155 to make it do what we want to do. So we've applied power to the system, and the first thing we have to do is address the control register in the 8155. So we've set the I/O and memory switch to the I/O position. This tells the 8155 that we're addressing the I/O port pins on it and not the memory. We have all 0, which is the address of the control register, and we've latched that in. Now we want to load data into that'll command the 8155 to place port B into output mode, because that will operate the segments of the LEDs, and port C into output mode, which will allow us to use the transistor to select one display or the other. So the command to do that is 1 0 0 0 1 1 1 0, and we're going to write that right into that control register. When you do that, you should see a numeral 8 show up on the right-hand display. Why the numeral 8? Because the default data coming off port B is all zeros. This is because the chip has been reset. Now we can change the address to port B. The address of port B is 10. Latch it. And now we can alter the pattern on the display by choosing different data. For example, let's just write something random out there. Every time we write something different, the pattern of segments will change that's on the display. And you can see that the bit we just changed, if you look closely, was actually at the decimal point. Turning all of the bits off, or 0, lights up all the segments on the display. Now port C is used for a special purpose. Port C is used to control which display is getting the data. In software, the software, once it's running on the computer, will rapidly alternate the two displays, and it'll put the proper data into each display. This technique is called multiplexing, and one of the bits on port C is going to be used for that exact purpose. So let's try that to see if that part works. We're going to go out there to port C, and port C address is 1 1. So we've just told the device that we want to be on port C. Now, on port C, the least significant bit controls which display is getting the data. So if I write that least significant bit to a 1, you can see that now the left-hand display is getting all of the information. And if I went back to port B and wrote a different pattern, the number would change on the left display. If I write a 0 to the least significant bit on port C, you'll see that the right display comes on. The computer software is going to do this back and forth continuously while the computer is on, so it'll appear to you and I that there are two numbers displayed on the display, and it will not flicker. This again is called multiplexing, and it'll be handled by the operating system software on the computer. So there you have it. There's Lab 4. If this is working for you, great.